Hello, this is Mrs. James, and this is part 3 of our nuclear chemistry end of course exam review. I got a little rushed at the end of our last edition, nuclear chemistry part 2, because I have a 10-minute time limit. So let's spend just a minute talking about what we ended our last session talking about. We were talking about the risks associated with the wastes. So especially if a material has a longer half-life, there's a risk that that material is going to continue going through nuclear decay after whatever process, medical or industrial, is done. That can be a risk of radiation exposure to the workers or to the public, or it could contaminate the environment and affect the plants and the animals. So it's really important that people who use radioactive materials be thoughtful of the waste they create and how they affect the people and the environment. We need to remember that our planet is full of radioactive substances. Many elements are radioactive. There are industries who shift these radioactive materials around during processes. So they're not intentionally using radioactive material, but since they move radioactive material around, they also can create dangerous waste because it's radioactive. So, for instance, there is lots of water underground. That water can be used for processes. If that water is in contact with rocks that contain radioactive materials like uranium or thorium, so those things are in the rocks and the sediments, then the water itself can become contaminated. So a plant that uses that water might create waste that's radioactive. All right. Most coal contains uranium and thorium. So a industry that uses coal and burns it to create electricity can create waste that's radioactive, even though, again, they aren't intentionally using radiation to accomplish a purpose. And you can see I have other examples of that on here. So radioactive materials and half-lives and radioactive wastes are a pretty important part of our medical industry and of our industrial industries. All right, 2 more concepts. We are almost done with our nuclear radiation, nuclear chemistry section. This is the idea of fusion and fission. We've been talking about alpha and beta decay. These are both examples of what we would call fission. So here I have fission down here. When you have a material and it goes through decay and it becomes 2 smaller atoms, we would call that fission. And I was using the example before of alpha decay, when a substance or an element, specifically 1 atom of material, goes through alpha decay. It releases 2 protons and 2 neutrons. So this would be our parent atom, this would be the alpha particle, and this would be the daughter atom, whatever it turns into. And again, that's called fission. There's a totally different kind of nuclear reaction, though, that's called fusion. When fusion happens, 2 smaller elements are pushed together and they turn into 1 larger atom. A great example of this is hydrogen. If 2 hydrogen atoms are forced together, they will fuse into an atom of helium, which is very different from what we learned in our chemical reactions chapter. In our chemical reactions chapter, molecules would rearrange to form different molecules. This is elements actually turning into different elements. Fusion takes place in the sun. The things that we've been talking about in class, including using nuclear energy to make electricity, all use fission. Alright, so that is the last part of our nuclear reactions study session. If you did not see the first 2, I would encourage you to go and watch them on the YouTube channel.